Hello again, everyone. Welcome to our discussion of section 2.3, where we will continue with our visual exploration of graphs of functions in terms of their domain and range. Now, we've talked about domain and range before, right? Domain is the regions of the x-axis that are free from any restrictions within the function. In other words, we need to find out what are the restrictions along the x-axis. Visually, that means we need to look at the behavior of the function along the x-axis and see where the restrictions are, exclude those restrictions, and then what remains is the domain of the function. For range of a function, we do the same thing, but this time with respect to the y-axis. So we force our eyes to look at the behavior of the function with respect to the y-axis. We notice all the restrictions with respect to the y-axis, exclude those restrictions, and what remains is going to be the range of the function. Once again, before we begin, I'd like to remind you the best way to approach studying this subject, mathematics, and any quantitative subject. First, read this section before it is covered in class or in these videos. So reading, what I'm emphasizing is that reading is something we can never escape. It is part of learning. It is part of communication. It is going to be part of your success in the professional world. So please get into the habit of, it doesn't have to be a very long time, but just half an hour to 45 minutes. Just read through the section before it is covered. It could be right after breakfast or right after lunch, whenever your class is. Just take a look at the section before you watch the video or attend class. But read it. Read the section before it's covered. That's the key. Attend each class regularly, take notes, review your lecture notes, and solve all the problems you saw in the lecture on your own without looking at the solutions. And of course, complete all the homework assignments by the due date and review until you get an excellent mark in the course. Okay, so now, so for each of these graphs, we have a bunch of graphs here. We need to identify, write down the domain and range, and what I should have added here, and it's missing, it says, given the following graphs, find the domain and range, and write them using the interval notation. Okay, like that. Okay, so let's start with an easy one. When you learn something, it's always better to start easy and then build on that to more complicated problems. So in this case, we have a graph. To write the domain, force your eyes to look at the behavior of this graph with respect to the x-axis. Ignore the y-axis for now. With respect to the axis, do you see any restrictions along this graph? Is there any value that the graph is not taking? There is no such value, right? Therefore, the domain of this function, whatever function that generated this graph, is negative infinity to infinity. Now look at the behavior of this graph or this function with respect to the y-axis. Force your eyes to do that. I know two things are happening here. This graph is within an xy plane, but for a moment, force your eyes to look at the behavior of this function only with respect to the y-axis. Is there any restriction? Is there any value of y that this graph cannot take? Absolutely not, right? All values of y are attainable. We have no reason to believe that there is any restriction along this graph with respect to the y. Okay, so once again, the range in that case is negative infinity to infinity. That means there is no restriction. All values, all real values are acceptable values along this graph. Okay, this one. So we do the same thing. We have a graph. Let's force because we're going to write the domain first. So let's force our eyes to look at the behavior of this graph with respect to the x-axis. Never mind the y-axis. We'll look at that later. So with respect to the x-axis, this function is coming from negative infinity, right, which is here on this side. This is negative infinity, right? So it's approaching from negative infinity, and there is a gap at 1, 0. So there's a restriction there. We cannot ignore that. There is a restriction at that point. So, but the graph continues after 1, after x equals 1, right? So domain is negative infinity all the way to 1. Remember, force your eyes to look at the behavior with respect to the x-axis only. Look at this with respect to the x-axis. It's coming. In other words, so look at the behavior here with respect to the x-axis, because we're looking at the domain. So it comes from negative infinity all the way to 1. Then at 1 it stops, and then it continues after that. So parenthesis 1, positive infinity after that. So that's the domain. How about with respect to the y-axis? We do the same thing. We force our eyes to look at the behavior of this graph with respect to the y-axis. Okay? So with respect to the y-axis, this graph is coming up from negative infinity, right? It's coming up with respect to the y-axis from negative infinity. There is no gap, no restriction. As soon as we had y equals 0, not y equals 0, x equals 0, y equals 0, which is that point, there is a gap, there is a hole, there is a hollow circle. So there's a restriction at y equals 0, and then beyond y equals 0, the graph continues to go up, all the way towards positive infinity, which is that. So that's what I mean when I say force your eyes to look at the behavior of the graph with respect to the y-axis, with respect to the x-axis. That's what I mean. Okay, the red ones indicate the behavior of this graph with respect to the x-axis. The blue ones indicate the behavior of the graph with respect to the y-axis. So the range in that case would be negative infinity to 0, right? Union 0, infinity. Okay. So the next two graphs, this one is an upside down quadratic function, right? So to find the domain, you need to restrict your force your eyes to look at this behavior only with respect to the x-axis. With respect to the x-axis, do you see any restrictions at all? There is no restrictions, right? If you continue this line off the page, it'll be from negative infinity to positive infinity. There is no restriction. There is no value that this line cannot accept. Along the x-axis, it accepts all x values. Take a look at the behavior. So the domain is negative infinity to infinity. Now for range, force your eyes to look at this behavior with respect to the y-axis, right? What is happening? The graph is coming up from, with respect to the y-axis, it's coming up from negative infinity and it stops. It peaks. It peaks at some y value. What is that y value? Take a look at that. What is that y value? 2. At y equals 2, the graph of this function peaks. It does not go any further than that with respect to the y-axis. So we need to write that down as part of our range. So the graph comes up from -infinity, and does it go through y equals 2? Absolutely. There is no gap there. There is no hollow circle. It goes right through vertex 1, 2. So comma 2 and then bracket. Bracket means that the line does attain y equal 2 value. Okay? I hope this is making sense. So again, you have to force when you write down the domain, you have to force your eyes to look at the behavior of the graph with respect to the x-axis. For the range, you have to force your eyes to look at the behavior of the graph with respect to the y-axis. So, because there are two things happening, right? Domain and range are two things happening at once. You need to be able to visually distinguish what the graph is doing with respect to each axis. Now, this one, if you haven't done this already, please pause the video, and for the rest of this worksheet, the rest of this worksheet 2.3, write down all the domain and range for those values, because I have the blank ones posted on Canvas, right? So you can download those and write down your own solution and then come back here. You can do one by one too, but my point is, please write down your own solution before you look at what I've done, what I do in the video. Okay, so I'm assuming you've done that and you're now back, and so let's continue. This function, let's look at the behavior of this function with respect to the x-axis, right? Is there any value that this function cannot take with respect to the x-axis? I ask this knowing that you're going to be able to imagine this arrow, this line, continuing off the page, off campus, off this planet, and it can go to infinity, right? And when it does that, there is no value of x that it cannot attain. So for domain is -infinity to infinity on both sides. This line can go on and accept all those infinitely many values. For range means force your eyes to look at the behavior of this graph with respect to the y-axis. So let's see what's happening. It's coming, if we continue this line, these two arms, these two lines are coming down from what value? They're coming down from positive infinity, right? They're coming down to from positive infinity, and there is a floor here. There is a point beyond which they cannot dip. And what is the y value for that point? Right there, it's been given to us. The y value for that vertex, the lowest point in this case, is given as y equals -4. Okay, so now we can write the range. Does it go through -4? Absolutely. It goes right through the vertex. So we can write bracket -4, comma, positive infinity. So we always put the smaller number on the left. That's what you see here. So -4 to positive infinity. I hope this matches what you wrote down on your own. Okay, so in this example, this is the famous graph of the cubic function. Looking at it, is there any x value that this function cannot take? I mean, when I ask that, assume these lines, arrows, are going on, extending to infinity on that side and negative infinity on this side, right? If you continue off this page, off this campus, then this will go beyond, this will accept all, this function will accept all x values on the negative side, all x values on the positive side. So there is no restriction along the x-axis, right? So the domain is negative infinity to infinity. Now, with respect to the range, what about the range? Is there any restriction? No. With respect to the range, this is coming up from negative infinity, goes right through 0, y equals 0, and continues towards positive infinity, right? So that the arrows that I've drawn look at the behavior of this graph with respect to the y-axis, which is the range of the function. So there is no restriction. Negative infinity to infinity is the range also. This next one. This next one is an interesting one, and it's the graph of the function 1 over x. This is 1 over x. That's the function for this graph. So there are two pieces, not one, right? Whenever you have more than one piece in any graph, it's for sure you have to use the symbol union to write the domain and range for the different pieces of it. Because you have two pieces, you write the domain for one side, then you say union the domain for the other piece, okay? So just looking at this piece, force your eyes to look at the behavior of this graph with respect to the x-axis. That means going like that. So this line is coming from negative infinity, again, with respect to the x-axis. And it's approaching what value of x? What value of x does this line approach? What is the value of x at that point? 0. So it's coming from negative infinity with respect to the x-axis, and it's approaching x equals 0. So for this piece then, we can write negative infinity to 0. Does it go through 0? Does it connect with 0? No. This is an asymptotic behavior. Asymptotic behavior, we will get to that later in this course, and also it's a very important part of trigonometry when you discuss conic sections in Math 127. So this is an asymptotic behavior along the corners here, these edges, and so it will never attain 0. So that will be a parenthesis, not a bracket. So that's just this piece. The domain for this piece is that. What about that piece? Well, union. Where does that line begin and end with respect to the x-axis? Well, on this side, where does this end approach with respect to the x-axis? Not with respect to the y-axis, with respect to the y-axis. Where are we when we're here? We are at near 0. Not at 0, because this is an asymptotic behavior, so it will never get to x equals 0, but we are near 0. So, parentheses, 0. How about that side? How about that side? How does it behave with respect to the x-axis on this side? Well, it's going toward positive infinity. There. Okay? So now we have to look at the behavior of this graph with respect to the y-axis. So with respect to the y-axis, take a look at what's happening. It's coming up from negative infinity here. Negative infinity. And it's approaching some y value. What y value is it approaching? What is the y value here? Because this line, see this line on this side is approaching that y value. What is that y value that it's approaching? It's approaching 0. So once again, range starts from negative infinity to 0, then that's that piece. What about this side? Well, on this side, this end is beginning right after 0, and it moves, and the line goes all the way to positive infinity along the y-axis. So union 0, positive infinity. Okay? I hope this is making sense. The next two graphs, this one has 3 pieces, that one has 2 pieces. Okay, so let's take a look at each piece here. For this piece, the line, we're writing the domain, so you got to look at the behavior of each of these pieces with respect to the x-axis, which is that. Okay? Your eyes are picking up all the information, which is what is this, these lines, these three pieces are doing with respect to the x-axis and the y-axis. You have to force your mind to just focus on the behavior of these graphs with respect to the x-axis as you write down the domain. So with respect to this x-axis, this line is coming from negative infinity and approaching some x value. What is that x value? Looking at the graph, it's x equals -1, right? This is -2, this is 0, so that's -1. Okay, so domain is negative infinity, comma, -1. Does it go through -1? No, because this line, dashed line, is an asymptote. So parenthesis. So this represents this piece. What about this piece in the middle at the bottom? Well, that piece with respect to the x-axis is coming from -1 to +1, right? Take a look at these dashed lines. These dashed vertical lines are asymptotes, and one is going through -1, the other one is dropping through +1, and this curve is going between those two along the x-axis. So union -1, 1, and this reflects the domain here for this second piece. So what about the third piece? Well, the third piece, with respect to the x-axis, it starts right after +1, and it continues all the way to positive infinity. So union +1, infinity. Okay. Range. Range, we have to look at all 3 pieces again, but this time we have to force our eyes to look at the behavior with respect to the y-axis. So let's look at this one, this piece at the bottom. It's with respect to the y-axis, it's coming up from negative infinity and it's going through 0. So negative infinity, comma 0. Should I put a parenthesis or bracket? If you said bracket, wonderful. It is true because this line is going through 0. So bracket that, 0 bracket. Now that's that piece. What about this piece? Well, union, that piece with respect to the y-axis, it starts right, let's see, where is that? Well, that's 2, so this has to be 1. So it starts right above 1, and it goes all the way to positive infinity. So does the second piece, the third piece. It starts right above 1. This is 1, because that's 2, right? 1, 2. It's this line starts right above 1 with respect to the y-axis and goes all the way to positive infinity. So union, parenthesis 1, comma, infinity. Okay, so this piece takes into account both of these pieces, the range for both of these pieces. So that's where we stop. Okay. Now, this one is the graph of this function that you see there. So now the domain of this, once again, we have to force our eyes to look at the behavior of these 2 pieces with respect to the x-axis. So I'm going to look at this one. This one, with respect to the x-axis, it's coming from negative infinity, and it's approaching some x value defined by this dashed line. And if you can see it on the screen, it's x equals -2. So the domain is negative infinity, comma, -2, parenthesis or bracket. Parenthesis, if you said parenthesis, it's correct because x equals -2, which is that line, is an asymptote. So this line, the graph can never touch -2. So it'll be a parenthesis. A vertical asymptote can never be crossed, but a horizontal one can be crossed. Okay? So that's the domain for this piece. What about this piece? So union, that piece with respect to the x-axis begins right after x equals -2. So parenthesis, -2, comma, and it continues to infinity along the x-axis. Like that. Okay? What about the range? Well, we look at the behavior of these two pieces with respect to the y-axis. Let's take a look at this one. This one comes up from -infinity with respect to the y-axis and reaches all the way to some y value defined by this dashed horizontal line. Okay? That dashed horizontal line has equation y equals 1. So this line is coming up from -infinity and reaches to, but does not cross this. Look at this behavior. It does not cross the horizontal asymptote. So we have -infinity coming up to +1, parenthesis, not bracket, because the way it looks, this line is not crossing that horizontal asymptote. Horizontal asymptote, like I say, it can be crossed, but in this graph, as they show, it's not going to. So union, the range for the second piece. The range for this piece starts, with respect to the y-axis, starts right above y equals 1, right? So parenthesis 1, all the way to +infinity, like that. Okay? All right. So this one on the bottom, for domain, we have to force our eyes to look at this behavior with respect to the x-axis. Well, what is it doing? What is this function doing with respect to the x-axis? Well, it's coming from -infinity, right? This is -infinity. And I'm dropping these arrows to show you the behavior of this graph with respect to the x-axis. It's going through some point here, and then it stops at some x value. It's very small. It's written very small here. I guess you can still see it. It's -1, -1. The coordinates of that point is -1, -1. So the domain is from -infinity, -1, right, along the x-axis, then bracket or parenthesis. Does it go through that point? It does. It connects to it. I mean, it doesn't go pass through it, but it connects to it. It's not a hollow circle. It's a filled-in circle right there. So we have to reflect that with a bracket. Okay? So what is the graph doing with respect to the y-axis? Well, it's coming down from +infinity, right? If you continue this will go to +infinity with respect to the y-axis. Then it stops at some y value defined by that point. And again, the y component, or the coordinate for that point, is -1. So the range is -1, bracket, because it does go through that. Bracket, -1, and we always start with the smaller number. That's why I started with bracket -1, comma, in +infinity, parenthesis. Okay, I hope this is making sense. This last problem is just an exercise in, usually what we have is a function. We give it some value and we calculate what f of x or y is. But here we were not given the function for this, which is likely some polynomial. Polynomials graph like this, okay? And we will get to those further down the course. But instead of the function, we are given the graph, and we're asked to look at the graph and figure out for each x value, what is the y value, y or the f of x value. Okay, so this whole line represents f of x, some function, some polynomial function. Okay, so for x equals -5, right there, -5, we can be ballpark close. We don't have to be perfect. If the graph is not clear, we don't have to be perfect. But let's assume for x equals -5, the y or f of x value is roughly 90, right there. So that would be 90. We're just visually doing this, right? So it's okay. If you wrote down 89, you'd still be correct. Or even 88, you'd be correct. But if you wrote down 60, probably you would be off, right? You'd be off. Okay, so -3, that's x minus 3. What is the value of the function there? 0, right? The value of y or f of x at that location is 0. -2, what is the value of the function at -2? So if this is 0 to 30, so that would probably be 10, right? 10. If you wrote down 12, you'd still be correct. Even 15, maybe not 15, because 15 would have been higher, right? But we're eyeballing all this. So 12, 13, even 14 would have been okay. Okay, so at x equals -1, that's x equals -1, the function is here, right? That's almost a little bit above, midway between 30 to 60. So I'd say this would be, let's say, so 45. Let's say if you wrote down 45, you'd be correct. But since I see it over the halfway mark between these two, I'm going to say 47. Like I say, if you wrote 45, 46, 47, you'd still be correct. At x value 0, the value of the function is where the graph line is, right? 90. At x equals 0, the graph is passing through 90. Y value 90. So 90. At 1, positive 1, right? The graph is going through, let's see, this is minus 120, 150. So this would be, I'd say 130 would be safe if we said 130. So 130. At 2, the value of at x equals 2, the value of the function would be on the line. So that's 150. At x equals 3, the value of the function is on the curve. So that would be, let's say, 145, let's say. 145. So it's turning back down. At positive 5, x equals 5, which is right there, the value of the function is on the line, which is 0. Okay? All right. We have come to the conclusion of another section here. Thank you for persisting through this, and have a nice day, and I'll see you next time.